Hi, welcome back to this channel. In this video, we're going to have a very quick summary about chapter reaction kinetics. Basically, if we read the question and then we notice that the question is asked about rate of formation or relate with the rate of disappearance, basically we are going to write the differentiate rate equation. However, if the question gives us the time and then ask us to determine the rate constant, basically we are going to use integrated rate law. Next, the question is asked us to determine the half-life. So again, we are going to use the formula half-life. So this is why it is important for us to know that what is the order of the reaction so that we can choose the correct formula. Next one, we have to mention about the suggest two factors that will increase the rate of the reaction above. So basically, because of the reactant given here is in the phase of gas, so basically we can either mention about the concentration, we can relate with the pressure. However, for the size of particles, it will be not suitable. Basically, size of particles is used for the solid reactants. Okay, next one, maybe we can also mention about the temperature. And then we know that there is another of the factor, which is the catalyst. But in this case, not all the reactions have the catalyst, and we also don't know what is the catalyst for this reaction. So maybe for this one also not suitable. Means that if you want to suggest the catalyst, you need to give the actual chemical formula of the catalyst. Beside the question that's related with the formula, sometimes we may have a simple question like this. Okay, so first this is ask us to calculate the rate of reaction. So basically, as we already know, the definition of rate of reaction is change of concentration of the reactant, concentration of reactant with time. So that means when we have the concentration and then we have the time, so we will able to determine the rate of reaction. And then please alert with here, they are asking us for each experiment, so you need to give 3 rate of reaction. Okay, and then also need to be alert the time, the unit of the time given here is in minutes, so that's why the unit here is molar per minute. Next one is the order of reaction with respect to respect to reactant C and D, and then you have to write the red law. So again, when we see that there is a table with the concentration of reactants and also the time, basically we are going to determine the order of reaction, and this method is known as initial rate method. So if we want to determine order for C, okay, order of reaction of C, so we have to make sure we choose 2 experiments at where concentration C have to be different while concentration D need to be similar. So by holding this idea, then basically you will know which 2 experiments have to be chosen. Next one, state the effect on the reaction rate if the concentration D is double, concentration C is remain constant. So for this question, like we discussed in the tutorial, we will get the idea first. What is the rate of the order K concentration C to the power of X and then concentration D to the power of Y. So if you want to determine the effect on the reaction rate, either is increase, decrease or remain constant. So always assume initial concentration equal to 1 molar. So when we say that concentration D is double, that means that concentration D will equal to 2 molar, while concentration C remain constant, it means 1 molar. Then you will substitute into the red law, then you will get the effect of the reaction. Either is increased by how many factor, decrease, or even remain unchanged. Next part is about the collision theory, where you have to know what are the two conditions for the effective collision to happen. So basically is the molecules of the reactants have to be collide with correct orientation. So these are the keywords that we remember. And another one is with the energy equal or greater than the activation energy. So next question, they ask us about, they give, given the red constant, they give us the red constant at 100 degrees Celsius and 130 degrees Celsius. With, so this one will be T1, T2, K1, and this is K2. So determine the activation energy for the reaction in kilojoule per mole. As we look at here, it is involve the temperature. Then it's with two temperature. Basically, we are going to use the Arrhenius equation. Ln K2 over K1 equal to EA over R 1 over T1 minus 1 over T2. So when you substitute the value in, make sure the temperature must be in the unit of Kelvin, and then the gas constant that we use must be in the unit of the value of 8.314 joule per Kelvin, okay, and then per mole. So next one, so the value of K2 we have, K1 we have, T1 and T2 we also have, means we only left one unknown. So when you do this calculation, you have to remember that the activation energy that you calculate from this formula will be in the unit of joule per mole. But the question is asked us to in the unit of kilojoule per mole, so that's why you must convert it to kilojoule per mole by divide with the 1000. Okay, so basically I think these are the formula or the idea that you need to know in this chapter. So by referring to the extra exercise and the tutorial question that you did, then I think you supposedly have the idea. So that's all for this video. Thank you for joining this video. See you.